So in this lecture, we're going to be talking about how we translate a word problem to a solvable variable equation. So here's our situation. Jennifer is looking to buy a bicycle that costs $245. She's got some money saved, and she can save $15 each week to add to that total. Right? So how long will it take her to have enough money to buy the bike? Right? So a lot of people don't like word problems because there's a lot going on. There's a lot to keep straight. There's a lot to, you don't know what to do with everything. So I'm going to try as best I can in this lecture is to give you some kind of a checklist, if you will, as to maybe how we can organize what we have to make it make better sense to creating a variable equation that we can solve. Right? So if you want to take a word problem, create an equation from a word problem, first thing you got to do is you got to identify what the variable represents. It's not enough just to say, well, it's x. It doesn't matter what the letter is. What are we trying to answer? What question are we trying to get a number for? And a lot of the time, it's just the last question it's the only question in the problem. How long will it take her to save enough money to buy the bike? So X will be number of weeks of savings. We can just say number of weeks. We don't have to go any further than that. Okay. So we're saving for X weeks. So we know what the variable represents, and I really do think that will help kind of focus our thinking in this process. Next up, what are the operations? As we read through here, what are we going to do? Are we going to add, we're going to subtract, we're going to multiply, we're going to divide what? Well, if we look at this, I see right here, that's a pretty good, each week she adds $15. Okay, that's obviously, there's an operation right there in adds, but what are we going, is that addition or multiplication? Well, since she's doing it every week, it's repeated addition. Repeated addition means we're going to be dealing with some multiplication. And what else are we going to do? I mean, just put yourself in the situation. We've got some money already saved. So is that money going to get more or less? Well, we're going to get that number is going to increase. That amount saved is going to be increased every week after we add $15 every week. So we are going to have addition as well, even though it says add, and that really got us to multiplication. So we know we're going to create a variable expression that has both multiplication and addition. We know what x represents. It's the number of weeks. Now what to do with all these numbers? Well, we've got three numbers. Are the numbers coefficients, constants, or answers? Well, the coefficient is what's going to be hanging out with the variable. In this case, the coefficient is what we're going to multiply the variable by. Well, okay, so now we go back to what we'd underlined first here. Each week she adds $15 to her savings. Okay, well, that means I'm going to have 15x. I'm going to be 15 times x. So the coefficient is what's hanging around with the variable. It's what gets multiplied or divided by what multiplies or divides the variable. So in this case, every week we're going to add $15. So if it's 2 weeks, we've got $30 on board. If it's 3 weeks, 45, and so on and so forth. So the 15 is our coefficient. We don't need that anymore. We've already used it. Okay. That 125. When we're talking about what a constant is just gonna stay the same. No matter what happens with the variable, that number is going to stay the same. That number, 125, is going to remain is the amount that she has saved, regardless of how much she adds to the total. So starting this process, she had saved $125. Whether she saves for 10 weeks or 1 week, the number she started at is going to be 125. So 125 is a constant. That's not going to be with our variable. And since we've already used multiplication, we're going to add 125. And the bike's cost, that's going to be our total, 245. Because that's what we're trying to get to. And always put yourself in the situation. You guys are really pretty good at this. Put yourself in that situation, and what are you going to do? A lot of times, I've seen people that can do these types of problems better than just kind of the naked math problems. Like if I were to give you this one here, just by itself, people might struggle with it. But if you have a context or a real life situation, it gets a little easier. So there's our situation. We start with $125 and we add to it $15 every week that passes until we get to $245. Last step, solvey, right? How are we going to solve? Just like we normally do. This is one that you might want to take it one step at a time because it's going to be a little bit clunkier. So we're just to indicate that, yeah, we're taking it from both sides, but really the only math happens here on the right-hand side. We know that's just going to bring it down to 15x, and that's going to be 120. And then we're going to divide 15x and 120 both by 15 because that will get x by itself, which will give us an answer of 8. So she'll need to save for 8 weeks to be able to get her $245 bike. So when you're solving these word problems, really think about what is it that's going on. Identify what the variable represents. Try as best you can to determine what operations you have rather. What roles do all the numbers play? Are they coefficients, constants, or answers? And once you have it all put together, solvey. And remember, don't forget reasonable. Don't forget that you know what a reasonable answer is. All right, so now that we've gone through this, I want you to take a crack at that worksheet that I left you. Please reference this video if you need any help. Hope this helped.